Sense-making discussions are a prominent part of FOSS active investigation. Sense-making discussions typically follow data management as part of data analysis. Students typically stand in a circle, with the teacher as part of the circle, to facilitate discussion among students to build the analysis together. Sense-making discussions have two main goals. The first goal is to support students in analyzing data to extract meaning. This is done by asking questions, often utilizing a cross-cutting concept, such as energy. Here, students make sense of an experiment where they changed the amplitude of spring waves.
Let's think of the first activity that we did, where you tried to test different amplitude. And the question is, which waves have more energy, the high amplitude waves or the low amplitude waves? I'd like you to turn to somebody next to you who you don't usually work with and have a discussion with that person. Go ahead and pair up.
Like more kinetic energy.
They would move faster. Yeah, they were moving faster, so they had more energy.
Amplitude wave, if you go like really, really fast, it can be as powerful as a high amplitude wave, but it's less likely.
What I'm going to ask is for one person to share out, and it could be either something that you said or something that your partner said. And I would also love it if somebody feels like drawing on our class notebook over here to describe what you were saying. Who thinks they could take that on?
I think the high amplitude wave had more energy because the tape like in the middle was moving more, so you can tell that like it's moving more around.
The questions build in complexity throughout the discussion. In the beginning, students were asked to describe their observations. Now they will be asked to apply their thinking about energy, to compare the energy in the different observed waves. This allows students to build conceptual models about phenomena.
The tape would, it was like harder to get the wave started. Like it required more energy, and then the tape would move back and forth across, move farther than like the low amplitude wave. It would move like a little bit. And then on the high amplitude wave, it would move more violently back and forth.
Let's talk about the second experiment you did where we changed the frequency. What can you say about frequency?
When when he was moving it side to side, it had like more waves than the other one. The other one it was like moving like a lot slower.
I think the high frequency wave had more energy because it was like cresting more times, and as an anchor it was harder to hold it like still than the low frequency wave.
And like also I agree with that because like I noticed that the high frequency waves there was like more per second, or like more little waves occurred more often.
I agree with that because the low frequency wave, it was very slow and not fast moving as the high frequency wave.
That's a great start to the discussion. So let's get something we can look at. Can I have you go give an attempt to draw the difference between a high and low frequency wave?
The low frequency wave would go like more like that, and then the high one would go like.
Okay, great. And I like how you tried to keep the amplitude of the waves the same because we were trying to control amplitude. I need someone to go label this with high energy and low energy. Which one had more high energy and which one had more low energy? Why don't you tell us which one you'll label and we'll see if everybody agrees. So which is going to be your high energy?
Well, I'd say this would be high energy because there's more like kinetic energy.
I'm seeing a lot of heads nodding. Okay.
So should I just like write it here?
Yeah, great.
The second goal is for students to organize and communicate their thinking in collaboration with their peers. Through selected talk moves, such as turn and talk, all students are expected to participate, even if they don't share with the whole group. This prepares each student to record their own understanding in their notebook. A class notebook can be used to help students explain their thinking throughout the discussion. The Investigations Guide shows where sense-making discussions happen within the flow of the investigation. Sample questions are often included. The Sense-Making Discussions for Three-Dimensional Learning chapter describes how to set up the classroom and plan for different types of questions. How to include scaffolding, vocabulary supports, and class notebooks are also shared, as well as several grade-level specific examples. On FOSSWeb, a planning template is provided for teachers to use in conjunction with the chapter. Jumping into your first sense-making discussion with students can feel overwhelming. A good place to start is by setting class norms and using the questions from the Investigations Guide. With practice, students develop the communication skills they need to elevate their discourse and engage in authentic science talk.